Hello Math Analysis students. This video is going to go over the second page of the unit review for Unit Circle. Please note that on this page we are still in a non-calculator section, so we should not be using a calculator for anything here. Okay, for questions 13, 14, 15, it says given cosine of theta equals negative 3 over 5. Theta is in quadrant 2. Use this information to answer questions 13 through 15. We're in quadrant 2, so let's draw an angle in quadrant 2. Now it doesn't have to look perfect, but here's our angle in quadrant 2, here's our theta, here would be our right angle. In quadrant 2, of course, we know that our x value is negative and our y value is positive. Since we have cosine, that is our adjacent over our hypotenuse. Adjacent is, of course, our x value, so that is a negative 3, and our hypotenuse is 5. So our x value, or adjacent value, is negative 3, our hypotenuse is 5, and we need to find our y value. Since we have a right triangle, we can use the Pythagorean theorem. So negative 3 squared plus y squared equals 5 squared. That gives us 9 plus y squared equals 25. We subtract 9 from both sides. Y squared equals 16. And we take the square root of both sides, which gives us y is 4. We do need to look at whether that should be positive or negative. In the second quadrant, our y value will be positive, so y is just 4. So now that we have our x and our y and our hypotenuse values, then we can plug in to find these. Our cotangent is just our x value over our y value. So the x is negative 3 over the y value of 4. So that's negative 3/4, which is choice A. For secant, that's the reciprocal of our cosine, and cosine would be our adjacent over hypotenuse, so this will be hypotenuse over adjacent. Hypotenuse is 5, and our adjacent, which is our x, is negative 3, so 5 over negative 3 would give us negative 5 over 3, choice C. And then for the last one, sine, which is our opposite over hypotenuse. Our opposite is 4, our hypotenuse is 5, and so 4 over 5 would be our answer for this question. So 13A, 14C, 15D. Moving on to the next section. This one, sometimes students have a lot of trouble with this. For each one, true or false, we need to determine the value of what's on the left side and the value of what's on the right side and see if they are the same thing. You do need to know your unit circle for this. Okay, so for the first one, we have the sine of negative 2 pi over 3. We want to know if that's equal to the sine of pi over 3. So let's take a look. First of all, the sine of negative 2 pi over 3. Sine is just going to be our y coordinate. We're both looking at y coordinates here. Negative 2 pi over 3. We're going to start here and move in a clockwise direction. So 1 pi over 3, 2 pi over 3. Negative 2 pi over 3 is coterminal with 4 pi over 3. And the sine value for that is going to be negative root 3 over 2. So I'm going to make a note of that. This value is negative root 3 over 2. And now I want to find the sine of pi over 3 and see if it's the same thing. Sine of pi over 3. I'm going to use a different color here. Pi over 3. The sine, the y-coordinate, would be positive root 3 over 2. So we're comparing negative square root of 3 over 2 with positive square root of 3 over 2. They are not the same thing, and so this is false. Okay, for our next problem, I'm going to erase these colors that I drew right here and take a look at our next problem. Number 17, the opposite of the cosine of 11 pi over 6. Comparing it to the cosine of 5 pi over 6. Now, important to note that the negative means we want to look for the cosine of 11 pi over 6 and then take the opposite value from that. Okay, so cosine of 11 pi over 6. Let's find 11 pi over 6 on our unit circle. 11 pi over 6. It's down here. Our cosine value is root 3 over 2. Okay, so the cosine of 11 pi over 6 is square root of 3 over 2, but then don't forget this is saying we're going to take the opposite sign. So my left side has a value of negative square root of 3 over 2. My right side is asking for the cosine of 5 pi over 6, and 5 pi over 6 is here, and our cosine value is negative root 3 over 2. So my left side is negative root 3 over 2. The right side is positive root 3 over 2. Those are equal. So number 17 is true. Okay, let's take a look at number 18. Erase what I had here. Number 18, the cosine of negative 5 pi over 4 and the cosine of pi over 4. Okay, so for our first one, for negative 5 pi over 4, that is going to be, if we start here at our initial side on the positive x-axis, and if we go negative 5 pi over 4, that's moving clockwise. 1, 2, 3, 4. Negative 5 pi over 4 is coterminal with 3 pi over 4, and the cosine value there is negative root 2 over 2. Then we're comparing it with the cosine of pi over 4, and pi over 4 is in the first quadrant, and we'll have a cosine value of positive root 2 over 2. Left side's negative root 2 over 2, right side's positive root 2 over 2. They are not the same, so number 18 is false. Number 19 is asking us about the secant of negative 2 pi over 3 and the secant of pi over 3. So secant is the reciprocal of our x coordinate. Let's find where these angles are first of all. Let's see here. Negative 2 pi over 3, we'll move clockwise. 1. Negative 2 pi over 3 is coterminal with 4 pi over 3. The secant is 1 over our x value, or the reciprocal of our x value. Since our x value is negative 1/2, then the reciprocal of that is negative 2. Now what's the secant of pi over 3? Pi over 3 is in the first quadrant. It has an x value of 1/2, so it is positive, so that means the secant value of this one in the first quadrant is positive 2. We're comparing negative 2 with positive 2. They are not the same thing, so number 19 is false. It's kind of worth mentioning that most of these can be done without even actually knowing the actual x-coordinate or y-coordinate, but knowing which quadrant something is in. I'm going to go back and talk about that in just a moment. For number 20, the opposite of the cotangent of 7 pi over 6. Okay, 7 pi over 6. 7 pi over 6 is down here in our third quadrant. The cotangent, that's negative root 3 over 2, negative 1/2. So our cotangent x over y gives us a value of, excuse me, I had a technical error there. On this one, the cotangent of 7 pi over 6, we're going to have a negative divided by a negative, so that's going to give us a value of positive root 3, square root of 3. But then this is saying let's take the opposite sign of that, so my left side is negative square root of 3. On the right, we have the cotangent of pi over 6, and pi over 6 is in our first quadrant. X and y are both positive, everything is positive, so our cotangent is going to be a positive square root of 3. So on the left, we're looking at negative square root of 3, and on the right, positive square root of 3. They are not the same, so number 20 is false. Number 21, we are comparing the sine of 11 pi over 6 with the opposite of the sine of pi over 6. So 11 pi over 6, the sine value of 11 pi over 6 is our y value, which is negative 1/2. And the opposite of the sine value of pi over 6, so pi over 6 here has a sine value of 1/2. But remember, this negative out front says if the sine is positive 1/2, we're taking the opposite value, so this side is now negative 1/2. We're comparing our left side of negative 1/2 and our right side of negative 1/2. They are the same, so this is true. And once again, we could have pretty much gotten this without really knowing the values, just by without actually knowing very much about our terminal points. with pretty much just knowing things about where things are located and what's positive where. So if we think about all students take calculus, remember this tells us about which trig functions are positive and which quadrants. In the first quadrant, all of them are positive. In the second quadrant, sine and its reciprocal are positive. In the third quadrant, tangent and its reciprocal are positive. And in the fourth quadrant, cosine and its reciprocal are positive. So we could have gone through these and just taken a look at knowing which quadrant each is in. We could have known if we were going to have same signs or not. Signs S-I-G-N-S. For instance, in number 16, the sign of negative 2 pi over 3. Since negative 2 pi over 3 is down here in the third quadrant, that means our sign value will be negative. And sign of pi over 3 in the first quadrant, our sign value is going to be positive. So we're comparing a negative and a positive. They're not equal. That would be false. And we could have done that for each of the questions as well without actually needing to know any of the actual terminal points, since each is comparing like trig values. If we were asked about the sine of one number and the cosine of another, we would need to know the actual terminal points and trig values. But here, since they were the same function, we're really just looking at the positive or negative value of each. All right, finishing this up, name the quadrant. Number 22, the cotangent of t is less than 0, and the sine of t is greater than 0. Okay, so this means cotangent is negative and sine is positive. So we are looking for which quadrants. Well, sine is positive in quadrants 1 and 2. In the first quadrant, everything is positive. So number 2 would be the place where our sine would be positive, but our cotangent is going to be negative. For number 23, we're asked about the secant being negative and the tangent being positive. So the secant has to do with it's the reciprocal of our x-coordinate. We're looking for where our x-coordinate is negative, but if tangent is positive, that means that our x and our y are the same value. Tangent is positive in quadrants 1 and 3, but in quadrant 1, everything is going to be positive. So it is quadrant 3 where we would have that our tangent would be positive, but our secant would be negative. So this is quadrant 3.